Hi everyone, welcome to Saturday Night SQL Virtual Group webinar. My name is Sarah Huang. I'm the founder and organizer of this virtual group. Join me here is Debbie Huang, our co-organizer. Today we are happy to invite Warren Seifra, Warren Seifra, I hope I didn't butcher your last name, to present an introduction to big data. Warren has been in the IT community since 1998 has worked in a variety of industries deploying solutions utilizing Microsoft SQL Server in one capacity or another. In 2003, he decided to make SQL Server his mastery and has since developed skills in most defined disciplines of Microsoft SQL. Currently, he's a lead data analyst and managing consultant with DMI. He's responsible for BI solution architecture and delivery for Fortune 1000 companies, plus the mentorship of team members. He has been a SQL Saturday speaker since 2012 and contributed to SQL Saturdays and Azure Global Bootcamp and many user groups in 2015 alone. He has a passion for knowledge transfer and solutions architecture with a keen interest in info security. We really appreciate Warren spends his Saturday night to share his knowledge with us. Before I transfer the screen over to Warren, let me first go through a few slides regarding PASS community. As you may know already, PASS has launched the PASS Facebook Live pop-up expert with Bob Ward on February 7th at 1900 UTC. Each month, a new invited speaker from PASS community will join us for a 30-minute Facebook Live session to answer attendee questions in real time. You may like or follow the PASS Facebook page for upcoming RSVP details for this event. And PASS also has a career center. If you are interested, please visit pass.org/careers for more details. And the PASS Summit 2018 Virtual Group Referral Program they introduced a new code called Streaming Access to All PASS Summit 2017 content. If you use this code, this one is called VGSTRP9II. This is specific for our virtual group members. And if you use this one to register for PASS Summit 2018, the registration fee is $1,699 US dollars. But if you use this code, though, you can have access to the PASS Summit 2017 content. The goal is to provide first-timers a taste of what they can expect by registering for PASS Summit 2018. This code will be valid for redemption up until the beginning of the conference, PASS Summit. Attendees will be able to enter this code in the enter discount code field on the registration form. And the second one is our usual $150 discount. This code will be available after March 23rd, 2018. And also this code will be valid for redemption up until the beginning of the conference. You may choose either code number 1 or number 2, but not both. And PASS would like your help by providing a survey. So they would not like to know what types of sessions you want to see and topics you want to learn about and speakers you want to hear from. The plan is to provide a more innovative, content-driven experience, and the PATH needs your feedback. I have posted the survey link on the chat window if you can't see it. If you join late, you probably won't be able to see it, but I'll post it again. And there are some upcoming virtual group webinars. You can check them out. All these are past, I suppose. And this last page, this is what not listed on this upcoming virtual group webinars, so I added here. We have another one lined up this month on February 24th. It's called What is a Data Scientist and How Do I Become One? And I will put this the registration on our website once this tonight's webinar is over. And PATH has many virtual groups, and you may join as many as you like. And as always, you are more than welcome to join our virtual group, which is this one, Saturday Night SQL. And PATH membership is completely free. And these are the upcoming SQL Saturdays. You may want to check it out. This is how you connect with PATH. Sorry. You may connect with the PATH through Facebook, Twitter, or LinkedIn. And this is the Twitter handle. And this is how you may ask questions during our webinar. You may raise your hand if you like to interact with Warren directly by click this little hand sign. Then one of us will unmute you. Another way to ask your question will be entering your question in the chat window. Then Warren will read your questions out and answer them. Okay, that's all I have. Let me transfer screen over to Warren. And thank you so much, Warren, for spending your Saturday night with us and share your knowledge. We really appreciate that.
No problem. It's my pleasure. It's my pleasure. I am going to share my screen and kind of kick this presentation off here. Let's just get this going. So hopefully everybody can see my screen. As Sarah mentioned, my name is Warren Cifre, and I've been dealing with databases and just data in general for over 20 years. I have since, my title has changed since the writing of that bio. I'm a data analytics solutions architect, and the company is DMI instead of Allegiant. Allegiant was acquired. So I'm part of that, but who am I? Data professional for 20 years. I love doing obstacle course racing, Spartan races, Savage races, and yes, I am actually in training to be an American Ninja Warrior. I want to take on that obstacle. I want to destroy it. I want to just compete and see how far I can go. I have interest in all sorts of data stuff, everything from SQL Server to MongoDB, Hadoop, PowerShell, information security, which translates into hacking, essentially. I love the idea of how people get in, how do they do the things that they do, all these things we read about, the things we don't read about. And as a consultant, it's my job to be able to provide solutions that encompass all of these different technologies and more to ensure that the solution is as solid as possible. I'm also a founder and chapter leader for the NDBI PASS as well as ND Power BI user groups here locally in Indianapolis. As mentioned, I do a lot of SQL Saturdays. I do a lot of local and virtual groups, and I do a lot of non-PASS related conferences and user groups as well. And I've got alphabet soup when it comes to certifications. So basically, I'm not a moron. I kind of know what I'm talking about for the most part. I sometimes am wrong. So I do wish for all of you to please challenge me, hear what I'm saying, question, trust, but verify. Don't ever take anything I say at face value. Do your homework. Make sure it fits for you. tonight's agenda. Basically, what is big data, right? We hear this word being tossed around. It's a buzzword. All of our CEOs, all of our management, all the people that have control over the purse strings, you know, they're always saying, we need big data, we need Hadoop, we need all this stuff. And they keep throwing these terms around. And it's kind of nebulous as far as the definition goes. So one of the things we want to do with this presentation is kind of get a handle of what exactly is this big data, and do you have it? Do you not? And if not, at what point will you recognize that you do have it? So that's kind of the goal of that agenda bullet. The next one is why is big data a big deal, right? I mean, everyone keeps talking about it. We know big data is important, but why? What makes it important? What is so valuable about it? What are some of the sources of big data? Where does this big data come from, right? For us to know that we have big data, not only do we have to understand the definition, but what are the ways upon which this data arrives and falls under this bucket, this umbrella of big data? We also need to understand what's the technology that is related to big data. You know, in this case, we're talking about machine learning, we're talking about NoSQL, we're talking about all these different technologies. What are these things? And what's the relationship between that and some of the existing technology that we've been using for the last 20 and 30 years? And then how is big data being leveraged for organizations, right? We hear big data is important. We hear big data is the next revolution, advanced analytics, machine learning, all these hot buzzwords. But how exactly is this being implemented by some of the larger organizations out there? So I'll kind of talk through some of those scenarios. The one thing I want to make sure I make available here is if anyone has a question, please just type it in the chat window. If you wish to ask it verbally, just go ahead and raise your hand. Sarah, in between slides, when I change slides, if you want, please feel free to interrupt me if anyone has any questions. I like to make sure I try and answer the question within the context of the conversation. Sometimes the question, you know, saving questions at the very end, it might lose its sentiment or might lose its importance.
Sure.
So please feel free to interrupt as needed.
Okay, absolutely. Thank you.
And by the way, I tend to go pretty fast sometimes, especially when I do something that I'm excited about. So if you hear me pause, that's me personally trying to slow myself down and not just go at 100 miles an hour. So I do apologize for any moments of that. You're like, is he still there? Yeah, that's me slowing down, taking a deep breath and relaxing. So with that said, what is big data? Okay. You know, big data is a classification of your organization's data when it exceeds the traditional data management infrastructure. So what this means is we have all these database engines, we have all this hardware, we have all these SANs, so these hard drives, this network with all these communication lines, right? We have all this technology. And at some point, the data that's being generated, the data that we're collecting, starts to go beyond the capacity of those pieces of equipment, right? That right there is a sign that you started to have big data. Either A, you have so much data coming in that you don't have enough network infrastructure, or you don't have enough IOPS on your disk, or you don't have enough machines to be able to process the data that's coming through fast enough to move your business along. Those are key indicators that, guess what, you're approaching or you are there when it comes to the definition of big data, right? The other one is when data meets at a minimum one of the three V's, in this case, V's is in Victor, but ideally two or more. And in the industry, I mean, you can go out there and you can Google this, right? You're going to get your three V's, and you're going to hear four V's. And depending what you subscribe to will determine which one makes sense. But at the end of the day, all these V's are doing is providing a description of your data to determine whether you can officially classify your data as big data. So what are the three V's? The first V is volume. You know, everyone says, hey, I got big data because I got 100 gigs of data. Hey, I got big data because I got a billion rows. Hey, I got big data because I have a lot of data. You got to quantify it, right? What is a lot? Is a billion rows a lot of data? Now, a billion rows of a table that has two fields or two columns, that's not a lot of data. Now, if you have a billion rows in a table that has 500 columns and every column is filled with data, you might classify that as big data, because SQL Server and some of these other database engines will start having a hard time trying to manage a table that dense, that wide, and that deep. right? So this goes back to that previous slide, right? This piece here that says when your data starts to exceed the traditional data management infrastructure that you have. And the assumption is that the organization you work for has some, if not all of this traditional data management infrastructure. So the moment you start reaching the point where you start realizing that your backups are taking longer than your backup window, right? Your restores are taking longer than the time required. Your ability to synchronize your DR, your high availability servers, right? Those are moments where you start getting there. And a lot of times, it's defined as extremely large data. And then again, that's also very nebulous. So what is large? Very wide, very deep, a lot of tables, large databases, blob databases, right? What are we talking about? In this case, it could be terabytes up to zettabytes of data, right? So this is one of these. The next V is variety. The challenges with variety is that traditional database architecture, the way it's been done in the past, and let's just say data warehouses or ODSs, or even your relational databases, right? You have to go out there, you have to define a table. You then have to define your columns. You then have to define your data types. And then you have to define any primary keys.
Hello, is that me or
relationships?
Hello? I don't know if it's my network or it's yours, Warren. It's broken off.
Okay. Can you hear me okay speaking right now?
It's very clear. Keep going.
Hello?
Okay.
Warren,
I will keep going.
I'm not sure if it's my network or yours. I hear you broken off. So.
To me, it's fine.
Debbie.
Yes, to me, it's fine. No worry.
Okay. So Sarah, I will keep going, and Debbie, you let me know if there's any issues.
Sure.
Thank you.
Yeah, I can hear you now. To me, sorry.
So not a problem. So when it comes to variety, right, one of the challenges that we have with the traditional database architecture is that, hey, we want to augment our application. We want to add a new field. We want to add a new data point, a new capture point. Well, guess what? The application, all it needs to do is build its piece and the data's ready. But now for us to ingest and use that data, we now have to figure out what table is going to go in. We need to put that column in there, figure out the data type. Hopefully the data type matches that of the application. And we have to do that every time we add a new piece of data. And then we have to determine, is it allowed to be null? Must it always have a value in it? So there's a lot of rules of engagement when it comes to adding new data sets or new data to a relational database that we have to consider. And if you have an application or you have a data set that is very fluid, right, where the users can make whatever they want from an application perspective, that kind of falls under variety, right? So in this case, let's say you are an IoT manufacturer and you're developing sensors, and you build an application that says, hey, this application will collect data from the sensor. But then you offer a software development kit with the sensor that allows the purchaser of the sensor to build their own data points. Now, all of a sudden, your software that you give them to collect data and store this data may not necessarily meet their needs. So they may want to choose something else. And this is where variety comes in, right? Think of Twitter, think of Facebook. We can create as many fields as we want, as many things as we need. Twitter's constantly augmenting their API feeds and so forth. So one of the things we want to be able to do in the ingestion is to be able to store things in a way where maybe we don't have those constraints. But that variety causes an issue to where it exceeds the traditional data management infrastructure. The third V is velocity. In this case, we're talking about how fast or how this data lands in our infrastructure, in our network, and can we keep up with demand? So let's say we build an application, and again, we forecast that we have 1,000 connections. Can you imagine Facebook? You think Facebook was expecting to have billions of accounts with hundreds of millions of people making entries every hour, every minute potentially? And can you imagine trying to build a traditional infrastructure using traditional architecture to try and collect that information all at the same time and not lose any of it, that right there is a lot of concurrent connections and a lot of data flowing in one place very quickly. So that's kind of the velocity piece, right? So we're talking about high number of data records generated per second and high number of users requests per second. So when someone tweets something, I'm a follower, I'm requesting for Twitter to give me that information. Well, guess what? That's a lot of outbound connections for someone like the president or someone like, Snoop Dogg or pick your Twitter fan that you follow, right? Justin Timberlake. Doesn't matter, right? Pick it. But at the end of the day, it's velocity. So as an organization, for you to start determining whether you have big data, first, it needs to exceed your traditional. You need to start feeling some of the pain points where you're either having to buy more equipment or you're having to rethink your strategy on how your equipment's going to play for you. And your data collection and generation methodology must meet at least one of these V's for you to truly feel that you actually have big data, whether it's volume, variety, or velocity. In a lot of cases, you're going to find that you actually have two, maybe even all three of these. And most organizations that don't have quote-unquote big data, they're typically in that spot because they haven't taken the data to a low enough granularity level yet, or they haven't fully realized the value of their organizational data collection capacity, right? Who would have thought that Fitbit would be collecting just as much data per person as Facebook, or even more, because depending on the frequency upon which they pull data. And all it's doing is keeping track of heart rates. All it's doing is keeping track of GPS. All it's doing is a few little things, but it's collecting as much data as someone as Facebook, someone as Twitter. And that goes back to that realization, right? Every organization has the opportunity to generate big data. And if they're not, there's probably some reason that they haven't reached that point yet. So at the end of the day, what's the big deal with this big data? In my opinion, big data will most likely be the last big mindset change that will go, that will be undergone when it comes to data, right? It's a paradigm shift. You know, we're going from this concept of, we need a relational database, we need to create tables, we need to store data in a structured way for us to be able to report against it. And all of a sudden, this big data stuff, because of the velocity, because of the volume, because of the variety, we have to introduce new technology. And this new technology is a whole new mind shift, right? Who would have thought something like Hadoop in the entire ecosystem, or something like document-based databases like MongoDB and Cosmos DB? Who would have thought that things like machine learning and all these other elements would be needed to be able to bring about and leverage this data in a way that makes it valuable to the organization? And again, it kind of goes against everything that we've been taught for the last 30 years, that we have to build a table. We need primary keys. We need relationships. We need indexes, right? We need to provide a data type. Well, guess what? Document-based storage, you don't need any of that stuff. You're storing stuff in collections. You don't have to define a schema. Well, what? Yeah, no schema. You define the schema when you retrieve data. How can that happen? You're storing data in flat files. What's going on with that? Don't we want it in a database first so we can report on it? Again, a very big mind shift with regards to how we store data, and primarily because of those three V's and the fact that it exceeds the traditional architecture that we've known. Big data is the culmination of technological connectedness that stems from the human need of knowing, sharing, and feedback loops, right? We, human beings, the individual, you listening to me, are the ones that are generating big data. Whether it's being collected or not, it's a different story, right? I could take my Apple Watch off right now. I'm still having a heartbeat. I still have heart rate per minute. It's just not being collected. But we generate this data. And our need to share this information. How many of us went to dinner last night and took a picture of our dinner and posted it on Facebook? Or how many people are seeing Facebook posts from people that are doing that? I think that's comical, but that's my opinion. But at the end of the day, each individual has the capability, has this desire to share. I may not share my dinner, what I ate last night, via picture, but I'm giving this presentation because we all have this desire to share, right? We hop on our PlayStations, we have a game, we take a picture of this skill that we did, something we did on skiing, some picture with family. We're always sharing something. And then the feedback loop. When I share something, I want to know that people like it or hate it. I'm giving this presentation, but yet there's a SurveyMonkey piece at the end of this for you to say whether this presentation sucks or not, whether you like what you heard, whether you thought it was valuable, whether I was a good presenter or not. That's the feedback loop, and I want that. I want to understand how effective I am at communicating, how effective I am at sharing what I know through this feedback loop. And that right there is the culmination of big data, right? Is our human need for knowing, sharing, and providing feedback loops is what's generated all this big data. And big data allows for advanced analytics to be the cornerstone of the most groundbreaking innovations of the 21st century, right? 30 years ago, we dreamt about C-3PO, R2-D2. We dreamt about artificial intelligence. We dreamt about Skynet and Terminators and all these machines that are doing things for us, the Jetsons, right? All these things, Flash Gordon, right? All this fantasy, that this concept of electrical computations being done by a computer, eventually having a mind of its own and rolling through it. We're at a point now where we're reaching that point. We're at a point now where artificial intelligence, granted, it is still very grounded, it is still very infant, right? It hasn't been set free, so to speak, and we're very scared to do that as a species. But at the end of the day, this advanced analytics, the tools that have been used and to gather all of this big data information, is giving us the opportunity to start having autonomous driving cars like the Tesla. Start having things like Alexa and Siri be able to hear our voice, recognize the sounds that are coming out, make sense of it, translate it into something it understands, zeros and ones, make sense of what it translated, and give us an answer that we actually find valuable. And the more times it does it, the more effective and better it gets. So not only is it doing something programmatically, but it's also learning our behavior through all this big data capture and working its way through. So for me, this big data and this concept of advanced analytics is going, like I said, it's the cornerstone of the next 90 years, 80 years, right? It's going to be the thing that breaks us loose to the next thing, or let's be pessimistic, right? It terminates us, right? We develop Skynet, and away it goes. But regardless of which end of this story you choose to go down, there is no denying that big data is allowing, and the mindset of this new technology is allowing for this to potentially happen. So let's talk a little bit about this term of advanced analytics, right? You keep hearing it. People say, I want advanced analytics. Some people say, I have advanced analytics. Well, you know what? Let's talk about what Gartner defines this. And this particular slide is a couple years old. And the thing is, it's still very effective. And what you're seeing is the portion on the left is your traditional BI. And me as a consultant, the funny part is there are organizations that say, hey, I want advanced analytics. We're going to get Hadoop. We're going to get predictive. We're going to build some models and use R and get a data scientist and do all this stuff. But they still don't know what happened. They still don't have this descriptive analytics piece, which is the far bottom left. It's the easiest, least difficult to get, but they're still not there, right? They have these systems that have 2,000 to 3,000 reports, of which only 80 of them are actually used. They have these databases and these data marts that have duplicated data. They have data that's garbage and dirty and it's not calculated correctly, or it's very narrow in its use case, but yet they want this claim that they want to go straight to predictive. But you really can't do that, right? There's this maturity model that needs to take place. You've got to understand what's happened, and then you need to understand why it's happening. And then this line in the middle that divides the right and left side of this chart, imagine that being your real-time analytics, right? That's your operational. Those are the pieces that say, hey, right now on the plant floor, your pie making machine, your oven is running at 350 degrees. And if it goes in at 340, we need to stop and fix that, because that means we're undercooking our pies, which means we're undercooking the egg that's in it, and we might be introducing salmonella. And let's do a recall of that device, of that batch of food. So what happens is that, you know, you've got this diagnostic and analytics piece, which again tells us why it happened. Then we have the real time. Then we start going to the right. And if you notice the lines, right, you start reaching this advanced analytics, you start getting more value as an organization, but it starts becoming a little more difficult, right? This is where you need to have that creative piece. And predictive analytics is something as simple as determining what the weather is, determining whether a flight's going to be late, right? Determining whether what you're going to do tomorrow. That's predictive analytics, right? Now, prescriptive analytics is the holy grail. What can I do with the data that I know to influence an audience member to do something I want them to do? I am prescribing something. And an easy way to think of this, another way to think of this is when you go to the doctor, you feel sick, you cough, sniffing nose, you got the flu, you feel like crap. So what are you going to do? You're going to go to the doctor and get a prescription. What is the intent of this prescription? The intent of this prescription is that if you do this, you're going to feel better. It's going to stop your runny nose. It's going to stop you from coughing. It's going to cure your pneumonia. It's going to kill you. Whatever that pill does, it's going to pull you out of the matrix. It's going to keep you in the matrix. Either way, the idea is that you're trying to get to that holy grail where you can start prescribing yourself as an organization things to do that will then provide some behavior that will help your organization reach that next level of efficiency, effectiveness, financial acuity, right? Well, whatever it is they're trying to achieve, that's where you need to get to. And this portion of advanced analytics has been made possible because we've reached this precipice of big data. We have enough data to be able to generate predictive models. We have enough data, enough computational power, or enough computational power through the technology that's been developed that allows us to use it that way to be able to build these prescriptive analytics. Any questions so far? Are we okay with that?
I don't see any questions related to the content.
Okay, excellent. So I will keep going. So what are some sources of big data, right? We talked about what the definition is. We talked about kind of why it's important. We talked about how organizations can leverage it. But now what are some sources? Machines and devices, your cell phone, applications, your cable box, your computers, your Xbox, your PlayStations, your light switch, your car, your light bulb, anything, I mean, your Fitbit, your watch. There are shirts now that have embedded heart monitors in them. There are shoes that keep track of steps. All of these different devices, you know, and then let's take it a step higher, right? Let's go to the manufacturing plants. Let's go to logistics. Let's go to any of these organizations that have any devices that they build or use. Guess what? That's all generated big data. Again, web applications, research and development, R&D, right? Scholastic, education, all these people that are trying to invent stuff, they're pulling in data like crazy. They're generating a lot of big data. Social networks is probably the biggest boom of data and will continue to be the biggest boom of data in our generation, right? The more we want to communicate and the more variant we want our communication to be and more targeted our audience will be, will mean we have more applications, more devices. There'll be more people researching and developing against that, and it's all because of the networks that we're doing. And then again, GPS location services, that's kind of been around for a long time, right? But these are what I consider to be the five pillars when it comes to generating sources of big data. And anything that you can dream up kind of falls in one of these categories. So let's talk about the fun stuff, right? Now we're talking about the technology that leverages big data. So there's been this term tossed around called NoSQL. And it's been around now for about 6-7 years. And essentially what this means is it is a database storage engine or storage methodology that does not adhere to your ACID properties or your traditional relational database rules of engagement. So let's talk through some of that relational stuff, right? I want to insert a record into a table. What needs to happen first? Hey, I check the syntax of my query. Second, I check if the object exists. Third, I check if that table is able to accept new records. I then check to see if I can get my exclusive lock in the memory space for that table so that I can insert the record. I then block everybody else until I am done. I then have to check, do I have any indexes to update? And then I have to insert records into those after I get locks on those. And then once I'm done, I then release all that stuff. When all of those steps are done, that is when I've considered to be a successful insertion of data of conforming to the ACID properties of a traditional relational database. Now, let's switch over to something like a NoSQL type of database. I insert data. I don't care what table, I don't care what schema, I don't care what columns, I don't care who's using it, I don't care what indexes you have. I'm just going to pump it, put it inside of that collection. I'm just going to put it inside of that folder. I'm going to put it in that file. And I'm done. All of these other things that I did with the relational database happen after the fact. And they happen by some other application down the road. So what are some examples of NoSQL? Hadoop. And Hadoop is a broad thing, right? Because Hadoop is more of an ecosystem than an actual product, right? Because you got Ambari, you got Hortonworks and Cloudera, right? Cloudera's got Cloudera Manager, Hortonworks got Ambari, right? You have different flavors. There's about 10 to 12 different flavors of Hadoop out there, and each of them have their own ecosystems. So you can mix and match. You got Hive, HBase, all of these different tools, and they all have their own kind of use case, right? So, for example, let's use Hadoop as Hortonworks as an example. So, if we were to use Hortonworks as our NoSQL storage, the idea behind that technology is that when data is stored, it is stored on individual nodes. So think of it as you have a supervisor and you have workers. And the supervisor dictates where that work goes to. So when I store data, the data is stored at the worker level. The workers have all the tools they need to execute whatever task is requested. So they have memory, they have processor, they have disks that are isolated and used only by that worker node. When a query comes in and someone says, hey, I want to get all the blue cars, what's going to happen is all the nodes are going to be given the query, and each node is going to work at its own pace to look through the data it stores to determine where are all the blue cars. It's going to submit that information to the supervisor, and that supervisor will do anything else that needs to happen. It'll order it, it'll sort it, it'll do whatever aggregations or counts, and then eventually deliver the data. And what makes Hadoop a NoSQL is that when you insert data, it just goes to one of those nodes. There's no rules of engagement. There's no check if something is querying. There's no check if something else is writing to that resource. There's none of that stuff. Spark is another tool. Spark is an offshoot of Hadoop, right? Spark can be used in conjunction with some of the tools that Hadoop uses as well, right? So HDFS, your Hadoop distributed file system, right? That right there is a cornerstone of Spark. MongoDB, that is a document-based database that allows you to store things in collections, not databases. And in a collection, it is a JSON document or a collection of JSON documents that store things in JSON format, which are key-value pairs. But then you can have JSON documents embedded in those key-value pairs as an array. So now all of a sudden you can have this very complicated structure with no care whatsoever of what fields you have, and you create them as you need them. So there isn't this need to, I need to figure out what table it's going to go in and what columns it needs and data types or anything. So all of a sudden, I've eliminated that portion of my development to where I can write data to that collection ad hoc with whatever data I want. And as long as your application understands that, let's just say you have orders of purchase and orders of requests, and you have people that want to buy stuff, people that are asking for things, and people that are posting things. That might be 3 different collections. That might be 1, depending how your architecture is. But the idea is that all of them work autonomously, and the data is stored as quickly as possible. And then Microsoft has what was formerly known as DocumentDB, is now Cosmos DB, and it's kind of an offshoot of MongoDB, right? They actually have code that allows you to take a MongoDB compatible application and put Cosmos in that space without making any changes to your application. All of this falls under the umbrella of NoSQL. And you've got other things, right? You've got Cassandra, you've got, like I said, all the other varieties of Hadoop that are out there, they all fall under this umbrella of NoSQL. And because we're not bound by the ACID properties, and let me step back, right? MongoDB, I know for sure, is working on trying to add some ACID type of restrictions within their database environment. Because people have said, hey, NoSQL is great, but I really want this piece here from the relational database. So they've been adding things. So there is this beginning, and it's been happening for the last 2 to 3 years now, where what used to be the traditional NoSQL is starting to blend with the relational. And it's becoming an optional piece that you can switch on or off within this NoSQL technology. The next set of technology that big data is leveraging is, well, I kind of put it under the umbrella of machine learning. But this is not only a technology, but this is also a mindset, a type of resource, right? In the traditional world, we have data analysts, business analysts, we have report writers, we have DBAs. Well, in a machine learning world, we have data scientists. We have people building the machines, building predictive models, and we have these advanced analytics, right? So we've got this data science concept, and this is another term that has been tossed around a lot. Hey, I need a data science, or hey, I want to be a data science. How could I be a data science, right? It sounds like there's going to be a presentation on that in the coming weeks. That is fantastic because that's a question, right? And for me, I view this as a trisection of 3 different circles. One of the circles is understanding statistics. You need to have the mathematical computational understanding of what you're doing with the data when you're trying to come up with some kind of model and interpreting that model from a statistical point of view to be able to provide value to the organization. The other piece you need to understand is the technology that you use to apply that statistical information. And the third piece you need is the subject matter expertise of that particular vertical market or data set that you're working with. Most data scientists can get away with having 2 of those 3. I have subject matter expertise and statistical background. I will learn the tool. I have statistical background and I understand the tool. I will learn your business. I have the technology. I have the data. I will learn statistics. But to be a true data science for that vertical market, for that tool, you need to have all 3. And that trisection of the circles, to me, is the ideal data scientist for your business. Predictive models. Same, basically what you're doing here is what, for example, Amazon, right? You buy something. Let's say, recently, right, my whole fitness kick, I bought some Olympic rings so I can do some ring work like the people that do in the Olympic gymnastics, right? So I bought these rings. What do I get at the very bottom after purchasing that? Hey, people who bought this also bought this, and they bought this, and they bought this. They were giving me the suggestion, or what's called a recommender model, right? So based on what I purchased, I get that. Netflix. How many people have watched a Marvel show? All of a sudden, Netflix starts telling you, hey, because you like that, you may like these other Marvel shows. You might like some of these other TV shows that are older you may never even heard of. And based on characteristics, these models are providing you these recommendations, right? There are models that predict the weather. How many times in Indiana or any other state you have this severe weather alert, and what you'll hear is, oh, our models show, and we have a European model, we have a Canadian model, we have model number 3, we have model number 8, model XBY, all these different models. And what they're doing is that these predictive models are taking and leveraging this big data that's been captured over a period of time. We as the individuals, the data scientists, as the analysts, have to tell these models which of these data points are important to take into consideration and determine what relevance those data points have to those predictions. The acquisition of this big data and all of this, what is seemingly superfluous data, right? How many organizations out there are capturing every single network packet leaving their environment? Remember the Sony hack. Remember when the salaries of was Seth Rogen and the other guy from the movie regarding the North Koreans, right? There's this big hoopla where one person made 10 grand, the other one made 10 million for the same movie, and they started at the same level, and that all this Spider-Man stuff came out and everything else. Imagine if Sony were to be tracking all of their packets. I bet you they're doing that right now. All of that data means nothing until you need it, or until you build a model that can start leveraging it, looking at it and say, hey, this looks suspicious. Why? Because based on the last 3 years of traffic that you provided, data that you provided me, you have never done this. You have never transmitted data to, Syria. Why is data going there all of a sudden? Okay. And then again, we use the advanced analytics to be able to pull all this together, to leverage the data science, to leverage the predictive models. We have these advanced visualizations through tools like Power BI and Tableau and QlikView and all these advanced visualizations to give us the user interface to be able to interact with these predictive models, with these reports, and with this big data. And the last piece is cloud architecture, right? In the past, we've always known as the people that are in the scholastic world that are researchers, they always know more data is better, more data is better, more data is better. What hasn't been available until the last 10 years is the fact that we have computers now that can process this data. Capturing all this data is one thing. Being able to crunch it and see the correlations and see the regression models and see all these and apply these different training algorithms like neural networks and the cluster trees and all these other elements, right? We haven't had the computational power to do that. And only people that have the ability to invest in large machines and a lot of processors can do that, like NASA, like school systems, right? Universities and federal government. Now you introduce the cloud. Now you introduce the idea that, you know what, I want to push 2 terabytes of data up in the cloud. I want to crunch it. And then I want to get rid of those machines tonight because I got my results. I don't need them anymore. I'm done with them. And be able to do that in a week's time and not have to spend $1 million to get that level of computational power. The ability to rapidly prototype this stuff are things is just amazing. Especially it's what's allowing this leap forward in artificial intelligence, augmented reality, virtual reality, right? All of this stuff with sensors and IoT and everything is cloud has allowed that to happen. And in essence, all the cloud is data centers that are run by organizations that are exposing their servers to organizations to use. And they're the ones taking care of all the security compliance, all the lockdowns, all the backups, all the redundant power supplies, air conditioning, water retention, disaster preparedness, right? Wind, rain, earthquakes, all that stuff. They manage all of that. So as an organization, as an individual, you can find big data, you can generate big data, you can leverage cloud architecture to spin up NoSQL to collect this information, and you can leverage cloud architecture to spin up any kind of machine learning predictive modeling tool that you wish to use, and basically come up with your own stuff. So when it's all said and done, big data at the end of the day is in my opinion, the last big data revolution. Because I can't imagine what's coming next. And either A, I'm just not that imaginative, which is a possibility, right? I don't have all the answers. I'm just a normal everyday data monkey like you guys, right? Or maybe this truly is the it. This is truly the last big major data revolution. Any questions out there?
Yeah, somebody asked, must big data run on the cloud?
Must big data run on the cloud? No, it does not. Remember, at the end of the day, all you're dealing with is big data is that you need to be able to collect the data fast enough, you need to be able to have enough storage, and you need to be able to have enough a storage mechanism to handle the variety. But once you have this big data, which could be on-premise, I work with clients a lot where they're starting to establish a paradigm or a methodology for collecting big data. You know, I'm working with an automotive industry organization where they want to collect information from vehicles and be able to send emails out to fleet managers and being able to send notifications to people, but they want to collect it internally. So they're making an investment of purchasing equipment, purchasing enough network bandwidth, purchasing the right tools and the right architecture to be able to do exactly that. So no, it does not have to live in the cloud. The cloud is just a very inexpensive way and a very fast way to generate a proof of concept, put something together to show value to an organization. And then the determination can be made, do we need to make the investment of bringing this solution in-house, or do we keep it in the cloud, or do we conform to a hybrid approach, right? We bring the sensitive information in-house because it's some compliance work that needs to happen, and some of the ancillary data sets can stay out in the cloud. They're the biggest. We need to keep individual information in-house, but we keep all the detail, you know, all the stuff those individuals are doing out in the cloud because that's not private. Their names are, but not what they tweeted. So there's a variety of things that you can do here, but in short answer, no, you don't need to have big data on the cloud. It's just much easier to get the attention of the right people to prove out your hypothesis of how much value you can get from big data and to be able to show that it can be done versus, hey, this is a pipe dream. I wish we can do this. Does that answer your question? Hopefully it does. Hopefully it does.
And we got another one say, I see now that big data is available for my clients. How do I tell them that it's there? And more importantly, how do I tell them that it's valuable?
So to carry that conversation with the organization, the first thing that needs to happen is the mindset of the organization. You need to show them that data is value. Data is your most precious commodity. You might be a t-shirt maker. You might be a car manufacturer. You might be a service bureau. You might be a telephone company. You might be the one that makes the phones or the batteries of the phone. Yes, the batteries are important. But believe it or not, the data that you are collecting that allows you to produce that many batteries per hour, that allows you to control the cost of your labor, the cost of the support, the quality of your product, is probably just as important, if not more important, than the actual product you're shipping out the door. Because if you don't have insights into that data, if you don't have the realization that that data is going to save me money or make me money, and the loss of that data is going to cost me money at the end of the day, it's going to be very challenging to make anyone happen. So this first step needs to be, they need to monetize, understand that there's a monetary value to this data. The next thing that needs to happen for you to be able to convince them of how valuable it is you need to start providing them with situations that if they chose to store this data, what things could they do with it, right? You need to do for instance, a forecasting of how they can leverage this data. I don't know how many times I found myself in a situation where an organization tells me I don't have big data. And then all of a sudden I start being creative with what they do, with the types of services that they offer. And all of a sudden they start realizing, wow, I never thought of it from that perspective. Because at the end of the day, right, we are very perspective driven individuals. You know, we will look at something and we will say, oh my God, that's red. Someone will look at that machine learning octagon and say, you know what, that's actually purple. Because from my perspective, I am colorblind. And depending on the perspective, will determine how you choose to view things. And until that perspective is shifted or even shattered, only then will you be able to see what's right in front of you sometimes, which is the fact that that is an octagon, and depending on who's looking at it, they will see a different color. I'm a huge Star Wars fan, and there were moments in this latest Star Wars movie that were very big on perspective. And for those of you that have seen it, you will understand what I'm talking about. And that's the same thing that needs to happen to an organization, right? There is this belief, and you need to take them out of that belief that their data has no value, or that data is very narrow, or that they cannot collect this data, or that they don't have it, and be able to shift it so that they can see it. And that is a challenge. And depending on your audience, depending on the organization, the vertical that you're in, will kind of determine what path you may have to take, right? So I hope that kind of answers the question, or kind of goes down the path of where you need to go. There's another question that came in. How do you know the data you collected are correct for analysis and prediction? So first things first, right? Data is always correct. The question is whether the data has value towards the question you're trying to ask. So when you have all this data, the first thing you need to figure out is, what's your question? What are you trying to get out of it? What's the insight you're trying to glean from it? Once you understand what your first question is, the next step you need to do is, all right, what data points in this data do I think are relevant to the answer to this question? So let's say I'm trying to predict something. Let's say I'm trying to predict the weather. Now let's say my data set not only includes wind velocity, it includes the rotation of the Earth, includes the position of the moon, it includes the position of the sun, the time of day, the pressure in the upper atmosphere, lower atmosphere, and the temperature of the ocean, of the Pacific and Atlantic Oceans, right? I have all this data. What does the Atlantic Ocean temperature have to do with tornadic activity in the middle of the United States? To be able to predict tornadoes, what does the ocean temperature have to do with that? Well, in hindsight, you probably don't think so, so you leave that out. You will look at things like pressure. You will look at a few data points, and you will start plugging those into a model and seeing how well you can predict things. And again, I mentioned that you would build these data models using this big data. And typically you would build these data models using historical data. And the reason you would use historical data is because you already know the answer. So if you want to predict whether it's going to rain tomorrow, you need to understand what happened on all the days that rained in the past. And then you need to figure out what characteristics of those days are important enough to take into account. So again, let's go back to that tornado thing, right? We're trying to predict tornadoes. We have these different data points. We believe that we only need upper and lower atmosphere pressure. We need the temperature and barometric pressures. That's it. But all of a sudden, guess what? Maybe the temperature of the Atlantic Ocean, because of how high it is or how low it is, it may be causing a low pressure or high pressure in the jet stream, which changes the directionality of some of these pressure points, which now all of a sudden are causing this tornadic activity to go further south and eventually hit Kansas instead of staying in Indiana in a northern state. So that temperature that we didn't realize is out there. And that's a data point we have. We just didn't know. And the way it works is that you experiment with this stuff, right? You have a question. You have all this historical data. You start by picking variables or data points that you believe are important. And over time, you'll realize, you know what? That's not that important. That's not that important. This is important. Because at the end of the day, the more data points that you incorporate into your model generation, yes, it might be more accurate, but it also might take longer to process and generate that model. So that's where the trade-offs are, right? So there's this concept of supervised and unsupervised learning when it comes to building a predictive model. And supervised learning is basically saying, I'm going to tell you what I think is important to you, and you're going to tell me the correlations of those important data points. An unsupervised model says, here's every data point I have. I don't know what's important or not, You process everything as if it was very important and show me the correlations. In the circumstance where I have that supervised model where I'm telling explicitly which fields to use, it's going to return results faster because it's not trying to determine any correlation across everything, only those 7 or 8 points that I have. But you might miss the fact that the Atlantic Ocean temperature is very important to your predictive model. So you will have to balance that out. And this is where a data scientist comes into play, right? This is where you need to understand statistical modeling. You need to understand the idea that, yes, you can use a tool like Azure Machine Learning or a Watson to generate models. But if you've done something to your data incorrectly, such as overloading it, you're going to get the most accurate model on the planet because it's 100% correct with all of your historical data. But all of a sudden, you get real data, and you're trying to make business decisions. You're trying to do forecasts. You're trying to, make a $1 million or $10 million decision based on the forecast that you're getting on this. All of a sudden, you're wrong. It's because you've overloaded your data. Basically, you're giving it so much truthful information that it can't tell the truth from a lie. So when it gets all this data, it thinks everything is true, and it will give you the answer that you want, which is, yes, it's good. At the end of the day, it's going to be bad. Okay, and that's a very, very, very high level of the concept of overloading. All that goes down to predictive modeling, and all that goes down to the data set, and hopefully it goes back to your question, how do you know you've collected the correct data for analysis and predictions? You don't know whether you have all the data for the correct analysis and predictions. All you know is that you have this data, you have a question, and you're going to answer this question with the data that you have. And as you're going through that process, you will realize that you may do better if you had this other data set or if you had this other point of information that you can include in this. And that's where you start getting into the data munging process, and you start going into that data augmentation piece, right? How many of us have used something like Power BI or Excel, where we take data from 3 or 4 different systems? We take data from the stock market. We take data from, the latest commodities, how much, gold is worth, or how much something is worth for that day. Oh, and now we're going to use our internal data, and we're going to use data from clients that we get. We're going to use data from our vendors. We're going to use data from our suppliers, and we're going to come up with a model to determine what's important and what's not. But you don't know you're going to need that until you have a question. And you won't know you have a question until you start looking at the data and dream a question up. So at the end of the day, you need to have that question to determine whether you have the right data. And as you process that data, you'll realize you'll always want more. And then as you get more, you'll have to figure out which pieces are the most relevant of all the data that you have. And that's when you'll have a solid analysis. And unfortunately, that's what data scientists do. There's a lot of rinse and repeat of that, very creatively, but they do it, right? They do a lot of data manipulation. So hopefully that answers your question, Elva.
Hey, Warren, I have a quick question. Well, sometimes I observe that people have headaches because they're not sure what kind of data to keep, and sometimes they're afraid that they keep a bunch of junks, especially premise, then it doesn't provide value, also cost money to keep them. But on the other hand, they're also worried about if they get rid of those, they think they're junk at this moment, but maybe they're useful in the future. So what would you suggest for that kind of situation?
So the first piece is you will never know whether you're getting rid of valuable data or not. Because unlike as much as we're trying to, we can't predict the future of what the future is going to need from our past to help us predict the future better. Until a data scientist says, I want that piece of data because I believe it's relevant. So having said that, now you've got this concept of a data lake. We've all seen that. It's a buzzword, right? And Azure has a tool called Data Lake Store, Data Lake Analytics, right? Microsoft has, not Microsoft, but Amazon has their own stuff, right? You know, you got S3s and Redshift, right? You've got these different technologies that fall under the category of data lake. And the idea of the data lake is that you are taking your data and you are storing it in its rawest form, untouched, unmanipulated, no cleansing, no transformations, no formatting, nothing. It is the way it came originally from whatever device. You store it in this lake, and you just keep storing data. That is your ingestion. Your lake is your volume, is what manages your volume. Your data lake also manages your variety. And when it comes time for you to want to report off of the data that you do know you need from that, that is where you would use a tool like Hive, right? So part of the Hadoop architecture, you have a tool called Hive. And what it allows you to do, it allows you to build a database schema on top of basically a folder. And what can happen is that as you add more files, more CSV files, Avro files, text files, or whatever files that you choose to support as part of that schema, you keep dumping your raw data in there. Your Hive database provides this dynamic schema, so when something requests it, you can pull it. So let's go down the path of Microsoft, right? You got SQL Server 2016. It introduced a tool to the general public called Polybase. The idea behind Polybase is that it allows you to connect to Hadoop architectures, and it allows you to create what's called external tables. That Hadoop architecture external table connectivity, you would use Hive in between that. And what happens is that SQL Server can now read the contents of this data lake as it comes in, and is only reading the pieces it finds valuable. So as a data scientist, or as your business discovers that there is a new piece of data that you've been collecting for 20 years is now is of value, and you still have it, you can very quickly change your schema and be able to get 20 years worth of data out of your lake. That is the value you're getting by storing your data. Now, let's go to reality, right? None of us have an unlimited budget. None of us have unlimited storage space. The beautiful thing is cloud storage is very inexpensive. It's expensive to get it there. It's not expensive to keep it there. So that's one option you can have. The other thing you'll probably want to do is have some kind of archiving, some kind of compression scheme, something to be able to either preserve that data. I know a lot of on-premise organizations, a lot of data centers that manage cloud environments actually still do this. There's still the concept of tapes, right? You got these tape backups. Well, who's to say that what you used to use to back up your entire environment, you can't repurpose that technology to back up the archival of data that you need to remove from your on-premise equipment so that you can store it in a bank vault somewhere and keep it safe, knowing that you're not going to ever report on those 10, 15, 20-year-old pieces of data. It's not on spinning disk. It's not on equipment. But yet you still have it in the event that someone requests it. Now, the logistics of that. You got to maintain that drive. You got to maintain a backup device to be able to read those tapes. Tapes don't last forever, which means you got to periodically read them and move them over once every 3 to 5 years, right? You got to swap out those disks. But at the end of the day, if you can preserve your data, there will come a time when you'll find value. Now, is it going to be next week? Is it going to be a year? Is it going to be 10, 20 years from now? And is there really, truly value in that? That's where you're going to have to deal with that ROI or value proposition, right? That's where you're going to have to say that in the event I need information that I am not currently storing, what is the possible value that I can get? What's the probability that that value is actually going to come to fruition? And is it something that is worth investing in? Because at the end of the day, it's an investment, right? You're not making any returns on it. You're hoping you get returns on it. You're hoping there's value. And that's where you're going to have to make that call, right? I've seen organizations, obviously financial institutions have to store stuff for 7 years. Other organizations, other data points have be 5 and 3 years. Others are 10 years, depending what kind of vertical market, what kind of interaction you have, and what level of compliance you have to deal with, which means you're guaranteed to have 7 years worth of data of certain data sets. Now, it all goes back to where do you think your value is going to come from? And that is where we as consultants, we as individuals, we as the data advocates for that organization, we need to be the ones that are creative. We need to be the ones to say, let's have someone take a look at this and come up with a list of maybe 10 to 15 items that they think might be valuable to the organization, that this data can potentially produce, and present that. And if none of that has any value or any impetus for anybody at the C-level, anybody with an office with a window, then you know what? Then you've got your answer. That's something you can probably purge. Now, they change your mind. Hey, you got the email that says you're covering your butt. You told me I can delete it. It's gone. You told me there's no value in this. It's gone. So I don't know if that answers the question or not, but it's a hard one to answer, and primarily because there is no right answer. It's contingent on the organization. It's contingent on their value proposition and the directionality of the organization, right? How much value do they want to give towards this advanced analytics potential?
Yeah, thank you. And there's another one. Does big data take less room to store the same amount data than normal relational database does?
Well, it all depends on what you're storing and how you're storing it, right? So if you take a text file, let's say you take 100 rows, right? You take a 100-row piece of data. You get a text file that has 100 rows. You take a database table that has 100 rows. Take a look at it. How much space is stored? Now, you can say that's not a valuable comparison because you've got the storage space of the actual table itself, maybe the primary key, if you got a couple indexes, right, in the relational table, where in the big data world, if you were to store it in a file system, there are no indexes until you choose to create them either on the fly or on demand. So storage can be a little finicky. Now, depending on the level of compression, that's based on the level of cardinality of the data, right? So if I have a flat file, a text file, and I have nothing but sentences where the only word that really changes is the third word, everything else is identical, when I compress that, whether I have 1 million rows or 1 billion rows, it's going to compress really tightly because there's not a lot of variance. My cardinality is very low. I take that and put it in the database environment, it'll still compress very tightly, but you still got the overhead of the table and the indexes, right? You're compressing all these additional objects that are created to help speed things up. So when it comes to big data, it's hard to say that it takes up less or more space. It's a matter of the type of data that you have and the level of compression you're able to achieve. I mean, you can sit here and take data and put it inside Power BI or put it inside Power Pivot and get 1 billion rows of data stored inside of Excel. Again, because you're able to get that X velocity engine to compress like crazy. But then again, depending on what the cardinality is, you may not even be able to fit 100 records in there because you got 2,000 columns worth of data. And Excel's like, ain't going to happen. Power Pivot's like, not going to fit in memory, right? So when it's all said and done, it's not that one takes more than the other. Big data, the idea behind it, big data will always be more data than what you can store in a relational database. In the relational database, you might store markers or pointers to that big data, right? Sort of like, think of it as being your fact table in a dimensional model, right? You'll have all your keys maybe in the relational database, but when it comes time to retrieve data, you're actually going to your big data architecture, whether it be a data lake, whether it be using Polybase, whether you're using MongoDB, or some other tool to be able to store the details of that, which the details is where all of the variety comes from, is where all the data comes from with regards to the space consumption. And that's where the cleanliness comes into play, right? Because, data quality is a big thing. And when you're dealing with big data, a lot of times data quality is the worst part of it. You talk to any data scientist, and what they're going to tell you is they spend 75 to 80% of their time trying to get the data to look a particular way. The other 20% is when they actually get to do the fun stuff, right? So that becomes a big thing. So I'm going to say no, but you heard all the qualifying data why I'm saying no. Relational database will not be bigger than big data. Big data will always be bigger, and primarily because of volume.
makes sense. Thank you so much, Warren.
Alrighty, so let's see, what do I have left? So how are others using big data? I'll fly through this because I know we're getting close. Actually, we're over our time, but I will try and fly through. No, we got till 10:30. We're good. Sorry, I'm used to doing hour-long presentations. So Rolls-Royce, right? That organization is kind of changed the market space when it comes to engines, right? So what they do is they build engines. They build aircraft engines amongst vehicles, other cars and stuff. But in the world of planes, what they've started doing is they no longer sell an engine to a plane manufacturer, to Boeing or Airbus or any of them. They're no longer selling engines. They're leasing mileage. So what's happening is when you buy a plane that has a Rolls-Royce engine in it today, Rolls-Royce will be the mechanics. Rolls-Royce will manage all the data. Rolls-Royce will determine when maintenance takes place, and they will go out there and perform all that stuff or outsource it to another company that's going to be doing it on their behalf. The airlines are no longer in control of that. And basically, they're leasing their engines by the mile. Airlines are paying by the mile for leveraging their engines. Now, why would you want to do that? Rolls-Royce is very protective of their brand. I've heard stories and actually confirmed a couple of them with their cars. You purchase one of their cars, you spend $500,000 on one of their cars, and you call them up and you say that there's something wrong with that car, they're going to fly in a team with all the tools and all the parts and fix that car in your location. They will leave, and what they expect you to say is that car never broke. They want to make sure that the Rolls-Royce name is about quality, uncompromised quality across the board. And what was happening in the airline industry is that, guess what? Airlines were trying to cut corners. You have all these strikes. You got a lack of mechanics. No one wants to work in this space. We can't make a lot of money. So guess what? The quality started to go down. Their engines were starting to get, their brand name was starting to get tarnished a little bit because of the lack of maintenance, the lack of attention that equipment needed to meet the level of quality that equipment was sold as. So they decided to take that back and just charge you for the miles. Another example are wind farms. I did a single Saturday last year in Southern California, and was talking with a gentleman. I gave a presentation on streaming analytics and talk about IoT and being able to manage and read this information. And he mentioned that he started playing with this as well. And one of the things that they're wanting to do, and have started to do, is basically determine that they've come to the conclusion that having all of those wind turbines on at the same time is not good for the maintenance and the quality and the durability of the equipment that they have. And not only the equipment of the turbines themselves and the alternators that are inside of those engines that the propellers are on, and not really engines, but they're just an alternator essentially. But also the transmission lines that are collecting that power and transmitting it back to the battery packs, right? What they discovered is that on a very windy day, if every single wind turbine is on, it's going to heat that cable that is collecting that information, that power, to a point that it starts degrading it sooner than it should because it's collecting too much. Or the batteries will start losing their life because it's being overpowered because there's just too much. So by having streaming data to able to take a look and see exactly what's coming through at the time and say, you know what, we're about to reach this. We need to turn off 2 or 3 turbines to maintain our power output, but yet not compromise the maintenance or durability of the equipment that we have in place. And what they've been able to do is save money on the replacement of parts, the labor needed to replace those parts, and even the necessity of having those parts on standby, because now they're able to predict more effectively, more accurately, how long this equipment will last versus the variance that was taking place prior. Another industry that's taken a huge leap into this IoT thing is transportation, logistics, the UPSs of the world, the FedExes of the world, right? Those guys, I mean, heck, even the insurance companies, right? Who is it? I think it's not Progressive, Geico, right? they have this little widget that you can connect to your car that they can track how you drive, and they're willing to give you 15% off of your insurance costs for doing that. Guess what they're doing? They're collecting your data from your car. Guess what? You have organizations that these big transit companies, right? They're making real-time decisions about where the next delivery is going to go in the event of a refrigeration unit failure in one of their trailers. I'm driving down the road. I've got 4 deliveries to make over the next 6 hours. I've got some fish. I've got some ice cream. I've got some toilet paper. My next delivery is an hour away, and it's toilet paper. My refrigeration unit sensor goes off and says, I am down. I've got enough refrigeration for 2 hours. My fish drop off is 3 hours away according to my current schedule, and my ice cream drop off is 4 hours away according to my current schedule. But if I deviate from my current schedule and I go straight to the fish and the ice cream, I can deliver both of those. And right now, my most precious cargo is that fish, because toilet paper is not perishable and melted ice cream is not as valuable as rotten fish. So at the end of the day, they're able to make real-time decisions and be able to push transit lines and transportation going in particular directions. As I mentioned earlier, I'm working with an automotive company that's actually working towards, building sensors to get real-time data about some of the parts that they manufacture for engines. And what they want to do is they want to be able to provide feedback to these fleets and say, hey, you know what? You purchased this particular device that contains one of our pieces of equipment. And the way you're using it, if you make these code changes, you download this firmware, it will give you better throughput. It'll give you better torque. It'll give you better fuel output, better mileage, right? And being able to do that by collecting this information. So those are 3 examples of how businesses today of just various, just very different vertical markets, how they're leveraging this. And, you can easily see this in manufacturing, right? You can easily see this in call centers, right? To be able to collect enough data, big data, to be able to predict that you're going to need a lot more people in the stores or on the phones on the day after Christmas or Christmas Day, or maybe the weeks after Christmas, or, at some point in time, some major event, because you've made that correlation, because you have enough historical data to make that, and you have the proper data scientists to use the proper data points to give you that. All of a sudden, you're either saving money or making money. And believe it or not, it's almost better for an organization to make money than save money. Because saving money, it just means you're not growing your market space. Making money, you're growing your market space. Now, if you can do both, that's the holy grail when it comes to financial fiscal responsibility, right? Not only am I cutting my costs, but I'm also expanding my market base. I'm growing from both directions. And that's where big data allows us to go to, right? Big data allows us to use social, allows us to use geolocation services. It allows us to use applications and devices and sensors and all this stuff to collect and hopefully find a use for it. With that said, how can I help you guys, right? I'm a consultant. I'm here to help. It's a big thing, and it's just a matter of what can you dream up. Any questions crop up since?
We have a couple more questions. One of them is there any big data sets publicly available for training on the big data tools?
Oh, there are a lot of big data sets out there. You can get data sets from the Census Bureau. You can get data from the Geological Survey sites and be able to get everything from earthquakes to you can go to NOAA and get oceanographic stuff. You can get to you can get weather stuff. You can get stock market information. I know of a gentleman who's actually taken on the task of using Spark to collect all of the data from Wikipedia and track the updates and the comments and the number of views on those pages over time, and start providing some value as to which pages are the most accurate and which ones are not. Now, you would think Wikipedia is this giant thing, but guess what? You can pull the whole thing down in 18 minutes with enough Azure devices. with enough cloud devices. And you put Spark on top of it, and you can process the data and be able to collect everything from Wikipedia and get your latest information in about 30 minutes to an hour.
Wow, that's...
So I mean, when it comes down to it, there are data sets all around the world, and you can generate your own, right? You can get yourself a Raspberry Pi. You can use your phone. You can, but there's plenty out there, right? What I would do is I would go to a lot of the universities' websites, right? One of the things I discovered is MIT, right? They actually offer their entire Scholastic curriculum for free online that you can use. And they have a lot of the data sets. They have a lot of the examples. A lot of the curriculum is there with all the code that you need to do to be able to learn what they're teaching in class. What you don't get is the piece of paper that says you're an MIT graduate. Coursera is another place where you can get your statistical background information and correlate that with some of this big data sets out there and be able to pull this stuff together and start playing with it. R is the technology that you probably want to start with in using, and maybe even Python, right? And start using those two as your base data sets or base tools from a data science perspective, and learn those, because the majority of data scientists or aspiring data scientists must know those languages. To the point that Microsoft's machine learning allows you to embed Python, allows you to embed R. SQL Server 2017 renamed their R services to machine learning services because they're going to start introducing Python as another language supported by that service, which means you can now embed Python inside of your stored procedures, just like you can embed R in your stored procedures. And they're going to continue going down that path. So yeah, there are a variety of data sets out there. You just need to figure out what you're looking for. And some of the data sets that are interesting, you might have to pay $15-20 to get access for it. But once you get it, it's going to be a huge amount of data out there. I mean, you can even collect data from Twitter, right? You can get yourself a Twitter account and pull data from Twitter. You'll get 1% of Twitter for free. You want more than 1% of the Twitter traffic, then you need to pay for it. But you can sign up to Twitter and get that for free. So you want big data? It's out there.
Yeah.
Next question.
Yeah, this one is, can you comment about graph database such as Neo4j?
So graph databases, right? So graph databases is a very different database type, right? It's not your traditional relational database. It is not your It's not your traditional document database, such as what I mentioned earlier, right? Your NoSQL examples that I gave. Graph databases are primarily used for network correlations, and what I mean is that social circles, right? Think of the game of six steps of separation between you and Kevin Bacon, right? You can find connections between people and things to eventually make your way there. Believe it or not, LinkedIn uses that database format. So when this says, "Hey, these are you just connected with this person," you might want to connect with these people also. How are they giving you these suggestions, right? They're giving those suggestions because they're graphing the clustering and the relationships between those individual nodes to each other. So you can do that with network traffic. You can do that with individuals. You can do that with social circles, social patterns, financial patterns. But the idea with graph databases is to be able to see those correlations and those degree of separations. That was the term I was looking for earlier, between one point and another. And a graph database gives you the opportunity to very quickly store the data in that manner and be able to pull that in that way. Versus a relational database, you got to store everything, and then you got to do all kinds of manipulation to be able to do all this. Okay, how many people know this? Now next query, now next query, next query. Graph database does this inherently, and it stores the data in that way based on the definitions that you choose within the data sets that you choose to store in them. So that's kind of the difference. In graph databases, Microsoft has theirs, IBM has theirs, and you've got Google has theirs, and AWS. At the end of the day, conceptually, all graph databases do the same thing. all document databases, whether it's Mongo, Cosmos, whether it's Amazon, Microsoft, it doesn't matter, right? They all conceptually do the same thing. What's different is how they're implemented and maybe some of the nuances on how to scale, how to shard, and how to manage those components. So I hope that kind of answers or provides some context or some background as to what graph databases are.
Yeah, wonderful. And this is just one comment by Mike. He says Netflix use graph database to predict movies you will like. I think you. Yeah, that's another example. All right, it's 10:30. Thank you so much, Warren, for the wonderful presentation. I really learned a lot from you, and I appreciate you spent your Saturday night and share the knowledge with us. That's really nice of you. Thank you so much.
Not a problem. Here's my contact information. Please feel free to reach out to me, connect with me, ask me questions. Look, worst case scenario, you send me an email, I don't respond. What does that mean? You're no worse off than if you never asked. So if you've got a question, you're curious, just reach out. I might answer.
Yeah. Cool. And this webinar is recorded and will be put on YouTube, if that's okay with you, Warren.
Yeah, go for it. Go for it.
Okay. Cool. Thank you, everybody, for attending. And hopefully I will see you in 2 weeks.
Alrighty. Have a good evening, everybody.
Thank you, Warren.